Hello students, welcome to my YouTube channel. Today we will start our second chapter of class 12th, that is electric potential and capacitance. So today we will start discussing about electric potential. So what is electric potential? Electric potential is not a new concept. क्लास 11th में आप लोग ग्रेविटेशन चैप्टर पढ़ाई किए थे, तो वहाँ पे भी हम लोग पढ़ाई किए थे ग्रेविटेशनल पोटेंशियल. सो जस्ट लाइक दिस हियर ऑल्सो वी आर हैविंग दैट इलेक्ट्रिक पोटेंशियल. सो व्हाट इज इलेक्ट्रिक पोटेंशियल? सपोज वी आर हैविंग ए चार्ज प्लस क्यू, so it is a point charge. So suppose this is the electric field of the charge. Now if we are having a unit isolated free positive test charge, unit isolated free positive test charge, which is initially is at an infinite distance. So the work done to bring that charge from infinity up to a point within the electric field, up to a point within the electric field of that charge is called electric potential. So electric potential can be defined as it is the work done to bring an unit isolated free positive point charge from infinity up to a point within the electric field of any other charge. तो ये चार्ज के लिए पोटेंशियल का डेफिनेशन होगा in that way. So the expression of electric potential for a point charge comes out to be 1 by 4 pi epsilon naught q by r, where r is the distance where we have to find out the electric potential due to this plus q charge. ये plus q charge के लिए है. Clear? It is a scalar quantity and it is not having any kind of direction. So it is simply a scalar quantity and its unit is volt. Its unit is volt. Now we have to find out the expression of this electric potential due to the point charge. Means we have to derive this expression of the potential. So for this we have considered a charge plus q, just like this figure. Considered that charge is plus q. Initially suppose we are having that plus 1 charge which was initially at an infinite distance. वो initially infinity distance में था, infinite distance में था. फिर उसको displace करके कुछ n point पे लाया गया है. So obviously F external will be along this direction. Will be along this direction. Clear? So which is at a distance x from this plus q charge. Clear? Now to bring that charge from point n to point m by providing an displacement dx, तो ये चार्ज को प्लस 1 चार्ज को dx डिस्प्लेस करके n से m पॉइंट में लाने के लिए वर्क डन, व्हाट वी कैन राइट? F external dot dx. This will be the work done by the external force and against the electrostatic force. Obviously this is plus 1 charge, this is plus q charge. plus 1 charge को plus q charge obviously इस तरफ रिपेल करेगा. That means electrostatic force will be along this direction. और displacement object का हो रहा है कुछ इस direction में, both are in the opposite direction. तो obviously we will have minus fe means electrostatic force के लिए जो force apply हो रहा है into dx, as because the angle between them is 180 degree. So dw. So to total work done, अगर हमको कैलकुलेट करना है, so we have to integrate it. So w will be integration dw minus fe. इलेक्ट्रोस्टैटिक्स फोर्स का एक्सप्रेशन होता है 1 by 4 pi epsilon naught q by x square dx. इनिशियली अब पॉइंट चार्ज को कहाँ पे लाके रखा गया है? एन पॉइंट में. आफ्टरवर्ड्स इट वाज डिस्प्लेस्ड टू द पॉइंट एम फ्रॉम पॉइंट एन. एन से एम पॉइंट में लाया गया है. सो इट विल बी द एक्सप्रेशन ऑफ द work done. So we are bringing that charge x equals to from infinity to x equals to small r. This limit you should remember properly. So minus q by 4 pi epsilon 0 integration dx by x square infinity to r. So minus q by 4 pi epsilon 0 minus 1 by x integration r infinity. So obviously it will have the expression 1 by 4 pi epsilon 0 minus minus cancel हो जाएगा, plus हो जाएगा. So obviously we will have 1 by r minus 1 by infinity. So 1 by 4 pi epsilon 0 q by r. So v, this is the work done. So this work done is stored as the electric potential within the system. So the expression of the electric potential will be 1 by 4 pi epsilon 0 q by r. This is the expression of the electric potential due to a point charge, and its unit is volt. Students, you have to remember its unit is volt. Students, our next topic is electric potential energy. Electric potential energy क्या होता है? If we are having two or more charges placed at a distance of separation, so वो जो system constitute करता है उसका जो total energy होता है that is its potential energy, that is its electric potential energy. मतलब इन दोनों के बीच में जो electrostatic force रहता है उसके वजह से जो energy generate होता है that is the electrostatic potential energy. और इसको रिवर्स करके बोल सकते हैं इस पोटेंशियल एनर्जी की वजह से ही क्या होता है, वी गेट द इलेक्ट्रोस्टैटिक फोर्स. सो इन बाय द डेफिनेशन ऑफ पोटेंशियल, पोटेंशियल का जैसे डेरिवेशन किया गया था कि वी हैव टू ब्रिंग ए +1 चार्ज फ्रॉम इन्फिनिटी, इसको लाना था फ्रॉम इन्फिनिटी अप टू द पॉइंट आर within the electric field. In same way, if we replace +1 charge by q naught, so electrostatic force का expression आ जाएगा 1 by 4 pi epsilon naught q into q0 by x square in the previous derivation. So again we will have the total work done, or that is the electrostatic potential energy is 1 by 4 pi epsilon naught q into q0 by r. So this will be the expression of the इलेक्ट्रोस्टैटिक पोटेंशियल, और इसका यूनिट होगा जूल इन एसआई सिस्टम. सो सिंपली वी आर हैविंग W इक्वल्स टू 1 by 4 pi epsilon naught q into q naught by r, and if we talk about the expression of potential, it comes out to be 1 by 4 pi epsilon 0 q by r. So this is nothing but your V. So W will be equals to V into Q naught. So V will be equals to W by Q naught. This is another expression of the electrostatic potential. So इसका भी unit आ जाता है volt, that is equals to joule per coulomb. This is the relation between electric field and electric potential. Students, again you have to remember these are all work done. That means these are all scalar quantities. Means we have to simply add or subtract. Now coming to the next part, that is relation between electric field and potential. Students, suppose we are having a uniform electric field. Suppose we are having a uniform electric field denoted by like this E. Clear? Suppose we are having a test charge q naught. Suppose we are having a test charge q naught. Clear? Now we are having 2 points. One is B point, another one is A point. So from this reference line, you can consider B point is closer, means ये जो डिस्टेंस है, डिस्टेंस का वैल्यू कम होगा, दैट मीन्स इट विल हैव ए पोटेंशियल सपोज v प्लस डी वी, और ए पॉइंट बी पॉइंट से दूर में है, दैट मीन्स इसका पोटेंशियल क्या होगा, कम होगा. सो लेट इट्स पोटेंशियल इज डी वी. ई आर एंड बी आर वेरी क्लोज पॉइंट्स, वेरी क्लोज टू ईच अदर, सेपरेटेड बाई ए डिस्टेंस डी आर. नाउ फोर्स acting, suppose this is the test charge q naught, so the force acting on this test charge due to this electric field, we can write F equals to q naught into E. This is the test charge, force experienced by this test charge, equation number 1. Now the work done by the external agent in moving this q naught charge from A to B, मीन्स ये क्यू नॉट चार्ज को ए से बी पॉइंट में लाने के लिए वर्क डन एक्सप्रेशन विल बी माइनस एफ डी आर. डी आर डिस्प्लेस किया गया एंड द फोर्स इज एफ, एंड एज डी आर एंड एफ आर इन द ऑपोजिट डायरेक्शन, सो दैट इज वाई वी विल हैव दिस माइनस साइन. क्लियर? सो वी कैन पुट दिस वैल्यू ऑफ एफ in this expression, so minus q naught e dr, this is your dw. So here we can write dw by q naught equals to e dr. dw by q naught, work done by unit charge, work done per unit charge is nothing but the potential. So here obviously we will have dv, here minus sign will be there, dv equals to minus e dr, or E equals to minus dv by dr. So E equals to minus dv by dr. So dv by dr is nothing but the potential gradient. The gradient term you also heard in class 11th in the chapter viscosity, जहाँ पे मिला था वेलोसिटी ग्रेडियंट. सो यहाँ पे मिल रहा है पोटेंशियल ग्रेडियंट, मीन्स पोटेंशियल, हाउ पोटेंशियल इज चेंजिंग विथ द स्पेस, द डिस्टेंस दैट विल बी गिवन बाय द इलेक्ट्रिक फील्ड. सो dv minus dv by dr will represent the electric field. So dv this पोटेंशियल का यूनिट होता है वोल्ट, a distance की unit meter. So from here we get that unit of E as volt per meter. Now let us see the example of a problem. Here we are having a system of plus 2e charge and minus 6e charge. They are separated by a distance 2a. Suppose we have to find the electric potential at the point P. We have to calculate the electric potential at the point P. So A, B. So VA means electric potential at the point P, which is at the middle, suppose midpoint. So VA will be 1 by 4 pi epsilon naught Q by R. Q means here 2E by distance is A. This is 1. Similarly VB, B के लिए potential कितना होगा, 1 by 4 pi epsilon naught minus 6E by A. Equation number 2. So net potential V net, ये बताया गया है कि potential scalar quantity है, so simply we can add. So V net will be nothing but VA plus VB. So 1 by 4 pi epsilon naught 2E by A plus 1 by 4 pi epsilon naught minus 6E by A. So it will be minus 1 by 4 pi epsilon naught 4E by A volt, या फिर उसका जो SI यूनिट होगा. Clear? So in this way you can solve the other problems also. I am just giving you one problem. So students, in the first problem there is a square of side A. 4 charges are placed, plus q minus q on its 4 vertices. You have to calculate the net electric potential at the center point O. And in the next problem there is a hexagon where the charges are placed like plus q minus q plus q minus q plus q. and side of the hexagon, each side is A. So here also you have to calculate the net potential at the point O. Clear? So these are the two problems you have to calculate, and you should post the answer in the comment box.